morning. Let's continue from where we stopped yesterday, the day before, with this exam paper, April 2021. So here we're dealing with moment of inertia. So this graph, if I'm not mistaken, should come out in, was it last year's exam? But I remember sketching that tan graph. Right, so draw the graph of y is equal to tan x from, we got a domain there from 0 to pi over 2, show the area bounded by the graph, the x-axis, and the line x is equal to pi over 4. Right, so let's sketch this graph. So we have y is equal to tan of 1x. The coefficient of x here is just 1. So when we're sketching our tan graph, we need to work out the period first. Right, so the period is the distance in degrees of one full cycle. So the period for the tan graph is always 180 degrees divided by the coefficient of x here, which is 1. And 180 divided by 1 is 180. Then we work out our step values. Step values are always the period divided by 4. Okay, so that's 180 divided by 4. Whether it's sine, cos, or tan, our step values will always divide by 4. But the period for tan is 180 divided by the coefficient of x, right, and divide by the frequency here, which is 1. But for sine and cos, it will be 360. Only for tan, it will be 180. So 180 divided by 4 is 45 degrees. Alright, now you can use a table if you want to. And then, but it's really unnecessary. But if you want to, you go to your table function on your calculator. And you got x, and you have y is equal to tan of x. And now, let's put in a few values. What is the domain? Where do we start drawing the tan graph? And where do we end? So we start at 0, we end at 180 divided by 2. At the moment, I'm just using degrees for my table. When we come to the integration, then we change back to radians. Okay? And it's best when you're sketching the graph using degrees. So now, we are starting at 0, ending at 90 degrees. So you know, on your calculator, I don't need to explain that. Now you will know. Right, the calculator, you've got your table function. You can type this out. Start value is 0. End value is 90 degrees. We are stepping every 45. So it's going to be 0 plus 45, which is 45 degrees, plus 45 again, which is 90 degrees. So now, when x is equal to 0, what is y equal to? Tan of 0, which is 0. When x is equal to 45 degrees, tan of 45 is 1. And then when x is equal to 90 degrees, it is undefined at this point. It is undefined at 90 degrees. Okay. Now, let's have a look at the shape. So I got 0, 45, 90 degrees. Okay. So it's undefined. You have an asymptote at 90 degrees. Okay, your asymptotes. So there's your asymptote at 90 degrees. Now we know that at 45 degrees, we reach 1. So there is my 1 here. So there's 45 degrees and 1, that is your coordinates. So now the graph at 0 degrees. When x is 0, y is 0. When x is 45, y is 1. As you approach 90 degrees, so as you approach 90 degrees from the left, as you approach 90 degrees from the left, your graph approaches positive infinity. Okay. Right. Now, let's have a look at what we're going to do. So we got the graph of y is equal to tan x. Now we also need the line x is equal to pi over 4. Now what is pi over 4? 180 divided by 4, which is just 45 degrees. So here is my 45 degrees. So you take your ruler and you draw a straight line here. So that is your 45 degrees. In radians, this is pi over 2 and this is pi over 4. So degrees, radians. There's it in degrees, there's it in terms of pi and radians. Label your graph. So this is x is equal to pi over 4 and this is y is equal to tan x. Right, so now draw a graph of y is equal to tan x. We got that. Show the area bounded by the graph, the x-axis. So show the area bounded by the graph, the x-axis, and the line x is equal to pi over 4. You can see that area clearly. This is the area. Right, this is your area. You can see it clearly here. So that is the enclosed area. Now, here you are told, so it's going to, you don't have to think here. You are told use a representative strip perpendicular to the x-axis. Right, so perpendicular. So here is my representative strip perpendicular to the x-axis. You can see that. Right, so that is our just 2 marks. Right, 2 marks. We got our graph. We can see the enclosed area. Now, next question. Calculate the moments of inertia about the x-axis when the area described rotates about the x-axis. Right, now. Well, they could have just told you calculate the moment of inertia when the area rotates about the x-axis. Then you must know, you find it Ix. Right, so 5.3.2. Okay, so we will find Ix. That's what we are doing. The moment of inertia about the x-axis. Now, what do we know? Right, so we know that our representative rectangle, delta with a breadth of delta x, is perpendicular to the x-axis. We know this representative rectangle, there's a chair you can see it's perpendicular to the x-axis. So therefore, 2 things now. Formula. So we know that I, moment of inertia, is going to equal to mass times k squared. Right. Also, volume will equal to, what method are we using for volume? If it is perpendicular, we are using the disk method. so let's start writing down the formula. So what do we know? We know delta I x, so that's moment of inertia about the x-axis is equal to mass times k squared. What do we know about mass? We know that mass is equal to density times volume. Right, so that's M is equal to P times V. Mass is equal to density times volume. So I'm going to go P times delta Vx because we are rotating about the x-axis. So this is delta Vx. And K is the radius divided by square root 2, and that's all squared. K is given by the formula the radius divided by square root 2. Now, this method, for this method, you know the formula. The formula is pi r squared h. So let me just write this down here. Your this method is going to be pi r squared h. That is the this method. So what is important here? Very quickly in the exam, you need to know which is your radius now. Is your radius in terms of x or is it measured in terms of y? So you know if you're going around the x-axis, your radius is in terms of y. You can't go around. If you're going around the y-axis, then your radius is in terms of x. Make sure. One mistake, everything goes wrong here. Okay, so this is going to be pi y squared delta x. Your radius is measured in terms, this is your radius y, so that's going to be y over root 2 all squared, and this becomes p pi y squared delta x, and that's square the numerator, square the denominator, that's y square root 2 squared is 2. So therefore this becomes p pi over 2 y to the power 4 times delta x, because y squared times y squared is y to the power 4. Now total. So now we put in our integration sign. We got our p pi over 2. That's y to the power 4. Delta x becomes dx. We are integrating with respect to x. And then we will be substituting our values b and a. Okay, now, so we know our pi x is equal to p pi over 2. What's our b and what's our a? Where does this area begin? It begins at 0 and it ends at 45 degrees, but in this case we're going to be using the radians. You know, we don't use degrees whenever we are doing integration, it's always radians. Right, so now this is going to be pi over 4, 0, that's y to the power 4. But what is y? What is y? So now you know, we check. There's y here. There's only one graph, so we don't have to go top minus bottom, but the bottom is actually 0 if you want to do it. The fact is, what is y? Y is equal to tan x. So that's tan x all raised to the power 4. So what knowledge do we require in order to work this one out? Okay, the integration should be easy because it's just a method. The main thing is the diagonal, knowing if it's perpendicular, what to do. If it's parallel, what to do. You know, that's the most important. This is easy now. This is just a method. Tan to the power 4. You know, if it's tan to the power 4, you follow your technique. Let's integrate this. So that's going to be p pi over 2. So how do we integrate tan to the power 4? We can write it as tan squared times tan squared. Tan to the power 4 can be written as tan squared times tan squared. Now, 10 squared, we change one of the 10 squared, not both of it. Change one of it. 10 squared can be written as sec squared minus 1. We use our square identity. These are powers of 10 and what? Now we will remove those brackets there. So this is going to equal to now. So this is equal to, we got our p pi over 2. I got my pi over 4, 0. 10 squared times sec squared. So that's 10 squared sec squared. And then 10 squared times minus 1 is minus 10 squared. And there's my dx there. Now, this is exact derivatives. This is a square identity. I need to simplify further. So that's going to be my p pi over 2. That's pi over 4, 0. So I got 10 squared times sec squared minus 10 squared. You know that there is nothing that you will differentiate that's equal to 10 squared. So it's not it's not a standard integral. So you need to change it. 10 squared can be written as sec squared minus 1. So you change 10 squared to sec squared minus 1 again. And there's my dx. Now it's all ready for integration. So this is multiplication, exact derivatives. The derivative of 10, not 10 squared, the derivative of just 10 is sec squared. That's an exact derivative. Here, this is a standard integral. When you differentiate 10, you get sec squared. So the answer is 10 here. So this one is not bad, but it depends on how you're doing it now. You've got no time for U-Substitution, but if it's up to you, it'll be fast enough. Right, so this is equal to p pi over 2. I'm going to integrate it. So what am I doing here? This is 10x all raised to the power 2. So there's my f of x to the power n multiplied by f prime. That means exact derivative. So therefore, this is going to be 10x. 2 plus 1 is going to be 3 over 3. Because exact derivatives. Okay. Here, that's going to be minus integrate sec squared. You get 10. Minus times minus is plus. Integrate 1. You get x. And you're done. Okay. Let's substitute. Where's my calculator? Right, so let's substitute our values. Now, make sure your calculator is in radians. We do not use degrees now. We need trigonometry here and integration. So you go shift mode and it's already in radians, and you can type out those here. So I'm substituting pi over 4. Okay, so let's see what we get. So when I substitute my pi over 4, I'm getting 0.1187314967. You got that? Minus, well, if you substitute 0, you can see 10 of 0 is 0, that's a 0, that's a 0. It's all just 0. Right, so now Everybody, anyone get the same answer? You must be fast. You must do it. Right, so now we take this answer 0.1187314 multiply it by pi over 2. So if I take this multiply by pi over 2, and then we get 0.18650299989, which is the same as 0.1. So this is times p 0.187 p. Alright, so that's what we get. And this is our final answer for here. We were not required to give the answer in terms of the mass. I don't see it here. I don't think it was just calculate the moment of inertia. That's all. So that's our 6 marks there. Move on to the next one. Our next question, let's have a look at the next one. Determine the x-intercepts and the y-intercept of the graph. Y is equal to 4 over 9 x squared minus 4. Make a neat sketch of the graph from -3 to 3. Show the area in the top quadrant bounded by the graph, the y-axis, and the line y is equal to -2. Use a representative strip perpendicular to the y-axis. Alright, we come to that. The main thing is the graph. Let's sketch the graph. Alright, so 5.4.1. So we have y is equal to 4 over 9 x squared minus 4. So for the x-intercepts, you let y equal to 0. So that means 0 is equal to 4 over 9 x squared minus 4. Solve for x. So that means 4 is equal to 4 over 9 x squared. So that means x squared is equal to 9. That means x is equal to plus or minus 3. You got that? Right, so x is equal to plus or minus 3. Now, y-intercepts. Let x equal to 0. So you let x equal to 0, and then y is equal to minus 4. Easy. Parabola. You can see that. Now, let's sketch this graph. Right, so simple graph, parabola. You can see the coefficient of x squared is positive. That means it's concave up. What else do we need to find? Turning point. If you want to find the turning point of the parabola, you make dy over dx equal to 0. So dy over dx, if I differentiate that, that's going to be 4 times 2, which is 8 over 9x minus derivative of minus 4 is 0. So you make this equation equal to 0. So 8 over 9x is equal to 0. So x is equal to 0 divided by anything which is 0. Okay, but here the turning point is the y-intercept. Anyway, If you substitute x is equal to 0, where is it? Y-intercept. When x is equal to 0, y is equal to minus 4. The y-intercept is the turning point. You can see that. So this is your 0, minus 4. This is 3, 0. And this will be minus 3, 0. Those are all the critical points. Okay. Now they say sketch the graph from minus 3 to 3 only. So your graph is actually coming here, it's coming down here, turning, and then going up. Okay. But we're not required to sketch the entire graph. It's just this part here. So there's my 3, negative 3. We stop there. Right. Because anything to the right of 3 is not defined here. It's not required. You can see it. Now, we got this graph, the parabola, let's label it. Y is equal to 4 over 9, x squared minus 4. What else do we need to sketch? So we got the graph, show the area in the fourth quadrant. So this is first, second, third, fourth quadrant. This is the fourth quadrant. Show the area in the fourth quadrant bounded by the graph and the y-axis and the line y is equal to minus 2. So this is minus 4, minus 3, minus 2. So here is, just use a different color for that. So minus 2 is here. Okay, the area in the fourth quadrant only bounded by the y-axis, the graph, and the line y is equal to 2. So this is the area in the fourth quadrant. You can see that. That is the area that we're talking about. That is the area that is described. Can you see that? Now, okay, let's label this line. This is the line y is equal to minus 2. Now, use a representative strip perpendicular to the y-axis. Use a representative strip perpendicular to the y-axis. So, there's your y-axis here and there's a strip perpendicular. You can see that? So here is a strip perpendicular to the y-axis, so that will be delta y. But anything else that we left out? No, this is 0, 0, the origin, and that's basically it. That is the first question, 5.4.1. Alright, now 5.4.2. 5.4.2 calculates the second moment of area about the x-axis. Okay, about the x-axis. Of this area described in 5.4.1. So you have to follow the instruction here. We're using a perpendicular representative rectangle. Now, so it's basically find I x. So the reference axis is the x-axis. You're clear with that? Right. Find Ix, they say. Calculate the second moment of area about the x-axis. So what do we know now? Right. So we know that this delta y is parallel to the x-axis. You're clear with that? It's parallel to the x-axis. So, if it is parallel, then we use the formula. So there's the second moment of area. is going to equal to area times distance from the reference axis. All squares. If it was perpendicular, then it will be area times k squared, where k is equal to your length divided by the breadth. But if it is parallel to the reference axis, we use the formula area times distance from the reference axis, all squared. Okay. So your distance from the x-axis is y. Measuring a y value. Distance from the y-axis will be x. Distance from the x-axis will be y. Okay. Now, what is area? What is the area? Area is equal to length times breadth. Let's write down the area here. Okay. Now, area is equal to length times breadth. What is the length from here to here? We are measuring, it's an x value there minus 0. You clear with that? The x value at this point minus the x value at that point, it's x minus 0, which is equal to x multiplied by the breadth. What is the breadth? Which is delta y times the distance from the reference axis. The distance from the x-axis is a y value, which is y all squares. Okay, distance is always positive. Now, total. We're going to integrate. So that's going to become x times y squared. We are integrating with respect to y. We are using the y values. Okay, the y value. So let's call them C and D. Now, we need to integrate with respect to y. We need to get x in terms of y. We need to make x the subject of the formula. Okay, so you need to make x the subject of the formula. So what am I talking about? This x here. This is the x value here. So this is the graph that we are dealing with. So let's make x the subject of the formula. So I got y is equal to 4 over 9 x squared minus 4. So I will have y plus 4 is equal to 4 over 9 x squared. Okay, that's y plus 4 is equal to 4 over 9 times x squared. So if I multiply, I'm going to get 9 over 4 times y plus 4 is equal to x squared. I got rid of 4 over 9 on the right hand side. By multiplying by 9 over 4 on the right, 9 over 4 on the left, and 4 over 9 and 9 over 4 will cancel. Now, x is equal to plus or minus the square root of 9 over 4 times y plus 4. So this is manipulating the formula. Okay. This is the entire parabola, but we are not working with the entire parabola. We are only working with this part here. Okay, and in the fourth quadrant, x is always positive. You can see x is positive in the first quadrant, x is positive in the fourth quadrant. Alright, you can see this is the positive x-axis. So therefore, x is equal to plus it will just be the positive square root of 9 over 4 times y plus 4, which is going to be 3 over 2 times the square root of y plus 4. The square root of 9 is 3, the square root of 4, 2. Now, we substitute. So D and C, where is your D and C? Okay. So your D and C is, your Y value at the top is -2. The Y value at the bottom here is -4. You can see that there's the Y value here. The Y value at the top here, the Y value at the bottom, integrating from there to there. So that's going to be -2 to -4. Right. What is x? X is, so what is x? X is 3/2 times the square root of y plus 4 multiplied by y squared dy. We are integrating with respect to y. Okay. Now, integration here, we need to use our, what method do we use here? This, we can use U-Substitution. Okay, because there's no exact derivative here. Okay. So the derivative of y plus 4 is not y squared. The derivative of y squared is not definitely not the square root there. So we can use a U-Substitution, special cases from M5. Remember the special cases example? Right, so that's exactly what we're going to be doing now. So what do I mean? Right here, I can let u equal to y plus 4. Right, if I let u equal to y plus 4, then I know that du over dy is equal to 1. So therefore du is equal to dy. Right, now we need to get y squared in terms of u, because everything needs to be in terms of u. So if u is equal to y plus 4, that means u minus 4 is equal to y. Clear with that? So now, square both sides, u minus 4 all squared is equal to y squared. Okay, so now we go back here. This is going to be 3/2. That's my -2 minus 4. And this is the square root of u. And y squared is u minus 4 all squared. Y squared, there's my y squared, which is u minus 4 all squared. And dy is equal to du. So now, nothing difficult, it's just we need to square this, multiply out. Good question. Yes.
So why on this side you divide by 4 and then you decide to multiply by 4?
Question is, why did I divide by
4/9?
4/9, okay.
On the side. And then
Right,
you decide
so,
to multiply.
alright. Okay, the question is manipulating a formula. So let me just do it here, alright? And then I'm going to erase it before I continue with this. So we got y plus 4 is equal to 4/9 x squared. Okay, let's do this step by step. Right. So now I want to make x squared the subject of the formula. So I'm going to divide by 4/9, divide by 4/9. Whatever I do on the right hand side, I must do on the left hand side. So what happens on the right hand side? 4/9 and 4/9 cancel, so I end up with 1 times x squared. And I'm dividing by 4/9, that means I need to multiply by 9/4. There's it. Does that answer your question? When you are dividing by 4/9, when you change the division sign to multiplication, you swap numerator and denominator. Okay, that's one way of looking at it. Right, the other way of looking at it is like this here. Right, this is a better way to think about this. So this is 4/9. I don't want 4 over 9, so I'll multiply by 9 over 4. 9 and 9, cancel. 4 and 4, cancel. Whatever I do on the right hand side, I must do on the left hand side. So 9 and 9 cancel, 4 and 4 cancel. I got x squared is equal to 9 over 4 times y plus 4. Whichever way you look at it, it must come to the same thing. Right. So that was manipulating a formula. Maybe other people were thinking of the same thing too. But now you can see. Right, so that was manipulating that formula. Right, so let's get back then to this integration problem. Now, from here, nothing difficult here. Okay, it's just simple. Square this, remove the brackets. So let's do that quickly. So this is equal to 3 over 2. That's minus 2 minus 4. That's going to be the square root of u. And that's going to be u squared minus 4u times 2 is minus 8u plus 16 du. So now this is equal to 3 over 2. That's my minus 2 minus 4. And then I'm going to remove the brackets. U square root of u times u squared. That's going to be u to the power 5 over 2. The square root of u times u there, that's going to be u to the power 3 over 2. And then square root of u times 16 is just 16 u to the power half. That's my minus 2 minus 4. That is du. We are integrating with respect to u. So I got my 3 over 2. Now let's integrate. So I'm going to integrate. That's going to be u to the power 5 over 2 plus 1. That's going to be 7 over 2 divided by 7 over 2 minus 8u. 3 over 2 plus 1. That will be 5 over 2 all divided by 5 over 2 plus 16u half plus 1. 1 over 2 plus 2 over 2 is 3 over 2 all divided by 3 over 2. Right, now what am I going to do? I'm going to substitute back for u. I can use changing the limits. Let me see if I'm going to do now. Let me just substitute back for u straight and do it one time. Right, so now that's going to equal to 3 over 2, and that becomes 2 over 7. That's u to the power 7 over 2. I'm just inverting there. Minus 8 times 2 is minus 16 over 5 times u to the power 5 over 2. 16 times 2 is 32 over 3, u to the power 3 over 2, and we're substituting minus 2, minus 4. So what was u? U was, where is u? I let u equal to y plus 4. Alright, let's substitute now. See what we get. So we got our 2 over 7, y plus 4, all raised to the power 7 over 2, and we got minus 16 over 5. And we got our y plus 4 again, all raised to the power 5 over 2, plus 32 over 3 times our y plus 4 all raised to the power 3 over 2. I'm substituting minus 2 first. So when I substitute minus 2, I'm getting 15.30044387. Double check me there. Right, correct. Now I'm going to substitute minus 4. And I get 0, obviously. Minus 4 plus 4 is 0. And it's just there, 0 there. So basically it's this answer here times 3 over 2. So when we substituted minus 2, we got that multiplied by 3 over 2. And then I get 22,950,66581 units to the power 4. Units to the power 4 because second moment of area, but there's a check. Area is already squared and this is squared, so square times square will give you units to the power 4. You can round that off. Round it off to 3 decimal places is going to be 22,951 units to the power 4. And that is our final answer for this one. Right, so that is the final answer here, 22,951, second moment of area. Let's move on to the next question. So this is using the advanced calculator to check my answer, and it is 100% correct. Alright, 22,950,66581 is exactly what we got for our final answer. Right, so now finally our last two questions. Question 6. Calculate the length of the curve given by, this is the equation of the curve. We're not required to sketch the curve, just apply this formula. And just use it. So what do we need to do? We need to find our first derivative. We need to square it. We need to add 1, then simplify it, and we will integrate. Okay. So now, here I have y is equal to 3 minus x to the power 2 over 3. Double check all those values are correct. This is 2 over 3. This is 3 over 2. All correct there? Alright, so now dy over dx. Alright, so what is dy over dx? We need to use the chain rule because we have a power, which is a number. You can see that. So we use the chain rule. So now that's going to be 1 times 3 over 2, which is 3 over 2. And that's 3 minus x to the power 2 over 3. And then 3 over 2 minus 1 minus 2 over 2 is 1 over 2. Times, now we differentiate what's on the inside. The derivative of 3 is 0. The derivative of this minus x to the power 2 over 3, that's going to be minus 2 over 3 x to the power 2 over 3 minus 1. 2 over 3 minus 3 over 3 is minus 3. Right, so now that is the chain rule. So we need to simplify. Yeah, we need to simplify this one. Right, so now let's see what happens. Okay. So here, if I multiply positive power, so therefore this remains on the top, which is the square root of 3 minus x to the power 2 over 3. There's the minus here. If you're wondering about the minus, there's the minus sign here. Now this you take to the bottom, and this becomes x to the power positive 1 over 3. Can you see that? Right, so you take this to the bottom, so the sign of the exponent changes. Right, now, what do we need to do? We need to square it, we need to add 1. Okay, so I'm going to go 1 plus dy over dx all squared. Right, so 1 plus dy over dx all squared, we squared, and then we add 1. So that's going to equal to 1 plus minus the square root of 3 minus x to the power 2 over 3 all divided by x to the power 1 over 3 all squares. Right, so let's simplify this. Right, so we square that. So that's going to equal to 1 plus square the numerator, negative square becomes positive. Square that, that becomes 3 minus x to the power 2 over 3. Square the denominator, this becomes x to the power 2 over 3. Okay. When you have a power raised to a higher power, you multiply the exponents. Right, now we find LCD. Because we got 1 there, we find LCD. So 1 plus dy over dx all squared is equal to x to the power 2 over 3 plus 3 minus x to the power 2 over 3 all divided by x to the power 2 over 3. So now, if you check what happens here, that's 0 there on the top, except we got 3. So this is going to be 3 all divided by x to the power 2 over 3. So that is the result of what's inside the square root. So let's substitute into the formula. Okay. Right, so the formula, we got s is equal to the integral. So our b and a, 0 to 2. So that's my 0, that's my 2. We got the square root of 3 all divided by x to the power 2 over 3 dx. Right, so a lot of simplification involved here. This is for the students who are going to get an A for N6 Maths. If you want an A, you make sure you are able to simplify properly. Right, so now, so we find the square root of the numerator, the square root of the denominator. Now, this is equal to, I got my square root 3 there. I got my 2, 0. Then this I will take to the top. Before I do that, let me simplify this here. I'm going to take this, okay, let me just do it step by step here, right? You get confused, huh? It's going to be 1 all divided by. Now, this square root here, is, I can write it as to the power half. Can you see that? So when you have a power raised to a higher power, you multiply the exponents. So that's going to be 2 over 3 times 1 over 2, which is going to be x to the power 1 over 3. Right, now I can take this to the top. So that's going to be square root 3, that's 2, 0, x to the power minus 1 over 3. And now it's simple from here. We're just going to integrate, substitutes. So that's going to be square root 3. And then I can integrate x to the power minus 1 over 3. Minus minus 1 over 3 plus 3 over 3 is going to give me 2 over 3, and that's 2 over 3, substituting 2 and 0. Right, so now this is equal to the square root of 3, substitute, okay, this is 3 over 2, x to the power 2 over 3. Okay, so that's equal to the square root of 3. So we got 2 to the power 2 over 3. How do we get to there? Let's check. So we got 3 over 2. That's x to the power 2 over 3. We are substituting just 2. And then I get 2, comma 3, 8, 1, 1, 0, 1. Okay. 2, comma 3, 8, 1, 1, 0, 1, 5, 7, 8. Multiply by square root 3, which is equal to 4, comma 1, 2, 4, 1, 8, 8, 9, 1, 1. So this is equal to 4, comma 1, 2, 4. Units rounded off to 3 decimal places. Right, so simplification, this is similar to some of the examples in the exercise in your textbook. But let's move on to the last one, surface area. Alright, so our last question in the N6 exam, surface area. So let's see which one was more difficult. The first one or the second? This is the surface area. The other one was not easy because of the simplification. Let's see what happens here. Alright, so follow the curve, x is equal to that. Between the parallel lines, rotated about the y-axis. Okay, so we're given these values to use. Normally you're given actual values like y is equal to 2, y is equal to 3. But now, look, this one here is not going to be that. You have to substitute everything without a calculator. So let's see what's going to happen. First of all, let's find out, this is the surface area formula. You'll find it, check page 6 and 7 of your formula sheets. What must we do? We need to find dx dy. We need to square it. We need to add 1. That's the simplification part. Okay, let's see what happens. So now, I got x is equal to that, so we know that x is equal to r squared minus y squared all raised to the power half. Right. So now if I go dx, dy, I'm differentiating with respect to y. I will have to use the chain rule because I have a power which is a number. So this is going to be half r squared minus y squared, and half minus what is? Minus half times the derivative r is a radius, derivative of a radius constant will be 0. The derivative of minus y squared will be minus 2y. Clear with that? Now, minus, 2 and 2 will cancel. So I'm going to have minus y all divided by the square root of r squared minus y squared. Rewrite with a positive exponent. Now, 1 plus dx all over dy all squared. What is my dx over dy? I just worked it out now, which is minus y all divided by the square root of r squared minus y squared. That's my dx over dy. And I need to square it. And then I need to add 1 there. Okay, so this is equal to, so now that's going to be 1 plus, square the numerator, Negative squared, positive. So that's going to be y squared. Square the square root. What's left is what's on the inside. R squared minus y squared. Right, now LCD. LCD has to be r squared minus y squared. So I'm going to have r squared minus y squared plus y squared all divided by r squared minus y squared. So my LCD is r squared minus y squared. I'm adding 1. So 1 times r squared minus y squared is r squared minus y squared plus that all over. What happens now? Minus y squared plus y squared, 0. So I end up with just r squared all divided by r squared minus y squared. Okay, now what else do we need to do? That is 1 plus that, so we're going to substitute into the formula. So therefore, my surface area formula, that's going to be 2 pi. Now, what is my upper limit? A plus h. And the bottom one is a, and then I have x, and then I have the square root of r squared all divided by r squared minus y squared, and there's my dy. Right, now that's going to be 2 pi. There's my a plus h. There's my a. What is x in terms of y? X is equal to the square root of r squared minus y squared. This must be simplified. The square root of r squared is actually the absolute value of r, but we're really dealing with the first quadrant here, so that's going to be r all divided by the square root of r squared minus y squared, and there's my dy. Now follow what's happening here? Now, cancel one time, you can see that? So therefore, we got 2 pi, and this is a plus h, and this is a, and you're just left with r. You're just left with r. You can see that? Remember, r is a constant, it's the radius, so you're not integrating r. You can even do this here. Put r here and put a 1 here. That's even better. Right, because 2 pi r is a constant. So now I got 2 pi r, and if I integrate 1, what do I get? This is dy, and that's going to be y. You can see that? Integrate 1 with respect to y, that's y. So I'm substituting a plus h, and then a. So now, that's going to be 2 pi r, that's going to be a plus h minus, so I'm substituting my upper limits, minus, substitute my lower limits, a. So I got 2 pi r, a and minus a, 0, I'm left with just h. Oh, it works out nicely in this example, I can see that, which is 2 pi r h, whatever those units are, area is squared. You must know your work properly if you want 100%. You have to make sure your simplification is 100%. Okay. And that will be all. For now, we continue next time.